Yeah, good afternoon, all of you. Is my voice is audible? Is I audible?
Yes, sir.
Okay, so let me finish this attendance part. तो वेट करते हैं आज बाकी लोग ज्वाइन करने के लिए. तो आज हम लोग वर्चुअल लैब में करेंगे, ठीक है? तो we'll perform the experiment on virtual lab. Meanwhile, we need to scan this QR code for the attendance. QR code को scan कर देते हैं attendance के लिए. फिर हम scan this QR code for the attendance. So today what we will do, so we will look how we will going to implement different experiment that we have learned till now. How we implement that in virtual lab. Okay.
सर टाइमिंग 12 AM का है. स्कैन नहीं हो पा रहा है.
एक मिनट, change कर. अभी ट्राई कीजिए. हो रहा है अभी? Is it fine now? Yes. अभी स्कैन हो रहा है.
Yes, sir.
Okay, so let us start the session. So all of you may copy this link. Okay, this is a link for the virtual lab for the computer science department. So this is basically a platform which is given by the IIT Hyderabad. Okay, so यहाँ पर हम लोगों ने काफ़ी सारे virtual lab डिजाइन किए. So we will look for the image processing. Okay, image processing lab. So this is the code for the image processing lab. What is the code? You can go to this website. Okay, CSC19 underscore IITH dot lab, which is virtual lab dot ac dot in. Fine. So here if you see the list of experiment अगर आप click करोगे, so these are the experiment that is available in the virtual lab. Okay, so these are the experiments. You can see these are the list of experiments which is available in the virtual lab. So if you see, again हम लोग देखेंगे in that we have already completed this one. How in the MATLAB, how to perform different distance and connectivity. How to perform the distance algorithms. Okay, then how to find the connectivity. We are already done in the MATLAB. Then as we are today started the image enhancement topic. Okay, now this lab is particularly about the how we can perform different arithmetic operation on the image. So basically, arithmetic operations are performed for the enhancement of the images. Fine. And if you see the furthermore, now we have also completed the Fourier transformation. Okay, how to convert a spatial domain to the frequency domain. Then we have something having the point operations. Okay, that we have covered today. How we can operate a point operator. Then how we can perform the mass operator or neighborhood operator. Okay, then how we can perform the image histogram. So there is a list of virtual lab is given. Okay, there is a number of virtual labs given, like image, how to perform the image segmentation, then image processing for the color images. Okay, monophorical operations कैसे करते हैं. So these are the I can say 6 plus 6 12 virtual labs given. So we will understand today. We will understand some of the virtual lab that we have already performed. So what we will do? So we will start with the Fourier transformation. Okay, Fourier transformer हम लोग देखेंगे कैसे virtual lab में काम करता है. Fine. So is it clear to all of you what we are going to perform today? So today we are going to perform. So whatever we written the code there ना the Fourier तो लास्ट क्लास में आपको याद होगा हम लोगों ने फोरियर ट्रांसफॉर्मेशन और कोसाइन डिस्क्रीट ट्रांसफॉर्मेशन किए थे मैटलैब में. ना अभी हम लोग देखेंगे कि वर्चुअल लैब में वो कैसे इम्प्लीमेंट कर सकते हैं. तो इफ आई क्लिक ऑन दिस, ओके, so here we will give here we will give different segments here, like segments like the objective, introduction, theory, procedure, experiment. Then there is assessment also there, quiz and assignment, and the reference is there for reference book. Okay, so if you look at this experiment, okay, for an experiment, Fourier transform, okay, Fourier transform. Now, what is the objective, main objective of Fourier transform? Can anyone say what is the main objective of FT Fourier transform? So main objective is you have to convert whatever image is given. Now whatever image is given, okay. So this is my image given of XY. Now I have to convert this image. Now this image is basically in spatial domain. Okay, the image is basically in spatial domain. So I will convert this image to the frequency domain. Fine. I convert this image to frequency domain. To convert this to frequency domain, I will use certain transform. Okay, either Fourier transform or discrete cosine transform. So in this case, we will use Fourier transform. So I will use the Fourier transform. Okay, so when I perform Fourier transform in this image, so it will be converted to the something like f of uv. Now this uv is nothing but the frequency domain transformation. And we know that the frequency domain can be represented in two different things. One is your amplitude, second is your phase. One is your phase and one is your magnitude. Okay. It can be represented to two different things. One is your magnitude or amplitude and second is your phase angle. This is our main objective. The main objective of this experiment is to understand some of the fundamental properties of Fourier transform. Okay, so the main objective of this experiment, so whatever experiment that today we are going to perform, so main objective is to understand some of the basic fundamental properties of Fourier transform. So first of all, you have to understand that Fourier transform is basically used to convert your spatial domain image to the frequency domain. Second thing you remember, when you convert this into frequency domain, you will have two different types of images here, or basically two different categories बोल सकते हैं. One we can divide as an amplitude or magnitude, and second as a phase angle. So when I combine these two, so what we get? We'll get actual frequency domain image. So we'll get the actual frequency domain image. Okay. Then if you perform again IFT, inverse Fourier transformer, then we will get back our original image in the form of digital format. That is in the form of spatial quantity. Fine. So this is something about the Fourier transformer. Okay, how we are performing the Fourier transform. So let us see the introduction part. So introduction part is very simple. So first of all, why we require Fourier transform? We can say that, like if I say how how many different types of number can be represented. Suppose I take say number 12. Now it can be represented in decimal format. Similarly, I can represent this in a binary format. Yes or no? Similarly, I can represent this number in octet format. Similarly, I can represent in a hexadecimal format. Okay. Either you represent in base 10 format. Okay. Or let me write base 10. Or you can represent in base 2. Or represent in base 8. Or represent in base 16. Okay. Whatever the representation, but actual number will be 12. Okay. Whatever the representation will be, but what is the actual number? The actual number will be 12. Similarly, the signal can be represented. Basically, the image which we are forming, this is nothing but a signal. Yes or no? Whatever image we are forming, okay, जो भी आपका image form होता है, that is nothing but the analog signal. Fine. Now the signal can be represented in a different format. So it can be represented in a spatial format. So if we are representing in digital format, that is called spatial representation. Okay. Or it can also be represented in a frequency domain format also. Okay, so what we are saying now, that analog signal, images are nothing but analog signal. Now this analog signal can also be represented, like number are represented in a different format. Similarly, I can represent this image in a different domain. Okay. Now, one of the domain we know that digital representation, which is your spatial representation. Okay, where is represented by f of xy, where xy is your coordinate and f is your intensity at that particular coordinate. Yes or no? Yes. So this is the way of representation in spatial format. Similarly, this analog signal, or I say image, this image can also be represented in a frequency domain also. Okay, frequency domain में भी हम लोग represent कर सकते हैं. Now to represent this frequency domain, what we need now, I need some way of transformation. So to represent this one, so represent frequency domain, so what we need to do now, I have to convert this image or special domain to the frequency domain with the help of this Fourier transformation. Fine. So this is nothing but another way of representation. Now this is our second way of representation, which is your frequency domain. Either I will represent in a spatial domain or frequency domain, then or any other domain you can represent. Any other domain you can represent. So basically we will talk about only these two domains here. One is your spatial domain and second one is your frequency domain. Fine. So as you can see here, what I explained, that is written here. A number can be represented in a many ways. Okay, as I already said, the number which is given, it can be represented in different ways. Either it can be represented in decimal format, binary format, or hexadecimal format. But what will happen? So whatever the way of representation that be, but the final output will be same. Okay, the final output will be same, whether you present in any one of them. Similarly, whether you present in spatial domain or you present in frequency domain, okay, आप स्पेशल डोमेन में रिप्रेजेंट कीजिए या फिर फ्रीक्वेंसी डोमेन में रिप्रेजेंट कीजिए, जो फाइनल इमेज होगा वो आपका एक ही होगा, अलग नहीं होगा. It is nothing but another way of representation. Okay. Similarly, like a signal can also be represented in a many ways that are more convenient for the certain type of analysis. And fact, what they're saying, why we are representing this one, the reason behind for representing this one, for analysis purpose. Now what will happen? Uh, Now, what is the benefit of frequency domain here? For the analysis purpose, we can use the frequency domain. Now, it is better convenient for the user or it is the system to analyze a frequency domain representation compared to the spatial domain representation. Like same example, when we write a program, so when we write a program, now for the machine, it will be very effective if the program is written in binary language. Yes or no? So what we will do, so we will convert this number to the binary format, then the machine will be compiled and executed. Similarly, to analyze any images, okay, to analyze any images or perform any certain operation of the images, the frequency domain will be very helpful. Okay, the signal that represented in a frequency domain are very convenient for analysis. And the most common representation is your Fourier transformation, which convert spatial domain to the frequency domain representation. Okay, so basically FTR most frequently or most commonly used, okay, which will be convert your spatial domain to the frequency domain. Fine. And the Fourier transformation is a way of expressing the image A in terms of, so as we know that whatever the image that will be converted out, it will be formed. Okay, Fourier transformation क्या करता है, जब भी convert करोगे, nothing but the image will be in the form of sinusoidal function. That means whatever the image or whatever signal is formed, the base function of this will be what? Either sine function or the cosine function. ठीक है, जो भी आपको सिग्नल आपका फॉर्म होगा या फिर जो इमेज का सिग्नल फॉर्म होगा, उसका बेस सिग्नल क्या होगा? आइदर साइन होगा या फिर cosine होगा. Fine. And it transforms the image from spatial domain to the frequency domain. As I already said, this will be used to convert to spatial domain to frequency domain. And each pixel represents a particular frequency containing in a spatial domain image. Similarly, each pixel in this spatial domain represents what? Intensity. Yes or no? Each pixel represents your intensity. Similarly, here each pixel represent what? It will represent a particular frequency. Okay, it will represent particular frequency of the pixel. I can say this is a particular frequency of the pixel. But in this case, spatial domain में क्या था वो? Spatial domain में आपका था ये intensity दिखा रहा था. Okay, what is the intensity level of this one? If it is a grayscale image, so what is the level of intensity? It will be 0 to 225. Okay, it has a level. So similarly, here also each pixel will have certain range of frequencies. Fine. So this is the introduction about what you understand by Fourier transformer. First of all, you have to remember, okay, like image can be represented in a different way. Or image is nothing but a signal. Okay, image is nothing but a signal. Now I can say the signals can be represented either in a spatial domain or let me write SD. SD stands for spatial domain, or I can represent this in a frequency domain. Okay, frequency domain. Let me write FT. जो भी इमेज है आपका, ठीक है, आइदर उसको हम स्पेशल डोमेन में रिप्रेजेंट करेंगे या फिर फ्रीक्वेंसी डोमेन. दोनों का इक्वलेंट होगा. रिजल्ट दोनों का जो रिप्रेजेंटेशन होगा, तो फाइनल जो इमेज होगा, दोनों का सेम होगा. दैट विल बी सेम. Fine. Then question rises here. Why we have to represent in frequency domain? Why? The reason is for analyzing purpose. If you want to analyze the data or analyze the image, the frequency domain will be more convenient. Okay, the frequency domain will be more convenient. That is the reason we are using this frequency domain. So how to obtain frequency domain? So the most frequently used your Fourier transformer. Okay, so FT is most frequently used to convert your spatial domain to the frequency domain, and each of this pixel in a frequency domain represent the intensity of the frequency, or frequency contained in each pixel. Okay, or each pixel will represent what is the frequency of that. But in this, it will represent what will be the intensity of it. Fine. So this is about the theoretical part of FT. What you mean by Fourier transformation. So I hope it is clear to all of you. Yes.
Yes, sir. Yes, sir.
Okay. So whatever we are saying, we will implement that one and learn. Okay. वहाँ पर देखेंगे, adjust करेंगे. Theoretical part पूरा जानना जरूरी है यहाँ पर. So yeah. This is completely theoretical part. So we have already covered this in the class. Okay. So I will not waste much of time. Now, as we know, this is the formula for what? Converting the frequency domain to the special domain to frequency domain. Now, this is the Fourier transformer formula, and this is the formula for inverse Fourier transformer. Okay. So we have already discussed, and we have also discussed the very important part here, that amplitude at frequency part. Okay. Now, if you see this diagram, okay, let me make it here. Now, if you see this diagram, fine. Now, this is my original image. Okay, this is my original image, and this is your what? Frequency domain differentiation. This is my spatial domain differentiation, and ये आपका जो है frequency domain differentiation. और ये frequency domain differentiation में आपका दो होता है. एक आपका होता है amplitude part और दूसरा होता है आपका phase part, phase angle. Fine. तो अगर यहाँ पर phase angle, the phase angle plays a very important role. Remember, okay. More and over, the amplitude of the images will be same, but the phase angle of the images will be very important. Okay. If you change the phase angle, then your entire image will be changes. Okay. So you have to remember this one. In a frequency domain differentiation, you will have it two sections. One is your amplitude part, second one is your phase angle part. And we also know the formula for that one. Formula क्या था? It is root over real part का square plus imaginary part का square. And it is tan inverse. It will be theta equal to tan inverse. It will be inverse of uv by real of uv. Okay. So this is already we are discussing the class. So that I'm not spending much. Okay, we already know what you mean by phase angle, what you mean by power spectrum, and what you mean by magnitude spectrum. And we also derived the equation for the FT and IDF. Fine. So we will. So you can see the three images here. Basically, this is your. I can say this is your magnitude spectrum. Okay, this is representative magnitude spectrum, or intensity level or frequency level of a Fourier transform, and this is your phase spectrum. Okay, and the final last one is your power spectrum. This is your power spectrum representation. Fine, three way of representation of there. Okay, one is your magnitude spectrum, second one is your space spectrum, and third one is the power spectrum. Similarly, we can see that as we move down, they have given the representation of very simple sinusoidal signal. Okay, now this is your vertical. This is first one is horizontal sinusoidal signal. So when I apply Fourier transform, now this is our final result. So what is the result? So entire thing is black. You can see entire screen is black, but a dotted white line, you can see a dotted white line that is placed at the center of this image. Okay, now this is nothing but a frequency domain representation of sinusoidal, or we can say horizontal sinusoidal signal. Similarly, this is your vertical sinusoidal signal. So when I apply Fourier transformer, Fourier transform on this image, you can see it will. This is your frequency domain representation. Frequency domain representation. You can see entire screen will be black. Okay, that's but there is a one it is a vertical line that is passing through, okay, at the center of the images. So this is your frequency domain representation for the horizontal and the vertical sinusoidal images. Fine. So we may not need these things. Okay, this is for only the theoretical part how it is actually performing. So let me check. We'll directly go to the procedure part. Okay. Yeah. So now what we have to perform. Okay. Now what we have to perform. Now here we will perform. Basically, I can say we can perform two experiments. Okay. The experiment is now you can write this experiment name. The experiment is to design, to understand and learn the Fourier transform concept. Now this experiment consists of two parts. Okay, first of all, we will convert the images to the Fourier transform. That means we will convert the image to the frequency domain using the forward Fourier transformer. Okay, फॉरवर्ड फोरियर ट्रांसफॉर्मर यूज करके हम लोग क्या करेंगे, इमेज को कन्वर्ट करेंगे फ्रीक्वेंसी डोमेन में. फाइन. सेकंड थिंग क्या करेंगे, वी विल स्टडी द इंपॉर्टेंस ऑफ फेज स्पेक्ट्रम. व्हाट इज द as I already said, the phase spectrum will play a very vital role in case of image transformation. Okay, then we will study what will happen if we'll be changing the phase spectrum for different images. So we will basically we are having two experiments here. So we will design the Fourier transform and we will study these two experiments. The experiment number one, we will perform forward Fourier transform. Forward Fourier transform basically used for, we will convert a spatial domain image to the frequency domain image. ठीक है. नेक्स्ट क्या करेंगे, वी विल डीपली स्टडी द कॉन्सेप्ट और इम्पोर्टेंस. व्हाट इज द इम्पोर्टेंस ऑफ द फेज स्पेक्ट्रम while image transformation. Fine. So what are the steps we have to follow? Very simple steps. First of all, step number one, what you have to do? First of all, there is a image is given. Okay, we have to select an image from option called select option. Okay, the image will be given. So for the input panel, okay, for the input panel, we will select an image from the given image by selecting the select image option. Fine. Step number one. Now the selected region of the image to be loaded into the input image panel. Now what happens? Once we have select option click करोगे, then we will get the select image option. Then we will select the region of image to the input panel to the image. Then once we select the panel, okay, then we will choose one of the options, that is what you want to perform, whether you want to perform forward Fourier transformer or whether you want to learn the importance of what phases. Now this is our option one. This will be our option one to convert the forward Fourier transform, and this is our option two. Okay. So first of all, we'll check for the option one, all the things for option one. Then we will go for the option two. Fine. Now, if you choose the option one, suppose we have chosen the option one, the forward Fourier transformer, then simply we have to click run button. Okay, run button. Now, what will happen? So, as soon as we click on run button, it will convert that image to this frequency domain. If you choose the option two, that is, if you want to study the different phase angle, then you have to choose any one of these given 5 or 6 choices. 6 choices are given. Now you have to choose any one of them. That means we have interchange. Now we have to interchange the phase angle with that choice. Okay. Then we will press the run button. Then it will automatically convert. Okay. Now the amplitude of one image will be merged with the phase angle with the other image. Okay. Then we can see the output will be displayed in the output panel. Okay, the output will be displayed in the output panel. Now, interesting thing is that in this experiment, so or we can observe this interesting thing. Yeah. So what the interesting thing is that when we perform advanced option with a different combination of parameter and compare the result. So when we will choose the advanced option and we will choose the different parameters, okay, and when we compare the result, then we can see a interesting things. Okay, so let me first show you how we can do that. Yeah. Let me go to experiment part. Now, I think all of you should having the laptops. Okay, we all having the laptops right now with you, so you can open this site so that side by side you can perform with me this lab experiment. So you can open the site. Okay, open the site. Let me share the site with you. So I just share the link with you, so you can open the site. So now, along with me, you can also perform that experiment. Okay, you can also perform this experiment, so it will be easier to understand. Okay? It will be easier to understand how we are going to perform. So here you can see there is two. You can say the panel is there. Okay, one is your input panel, and second one is your output panel. So one thing you have to remember here: the size of input panel and the size of output panel will be same or different. So when you convert any image from spatial domain to the frequency domain, so what will happen to the size of these images? This will be same or it will be reduced. Now, what is the size of the output panel? The output panel size should also be same. It is 300 cross. If it is 300 cross 300, now this will be also 300 cross 300. Fine. This is the first thing you have to remember. Okay. So, whatever the size of the input panel, that should be same as size of the output panel. So here you can see two panels are available. Okay. So clearly you can see here two panels are there. This is my input panel or input image will be inserted here, and this second frame, which is in blue color, here will be your output frame will display. Now here what will happen? The selected input frame will be placed here, input image. Let me write there, input image, and what will happen here? Your output image will be shown. Okay. Now, if you scroll below, I hope all of you already opened this one. Now, this is our input image, okay, from which we have to select a region. Okay, this is my input image from which I have to select a part of image from it, okay, or portion of image from it. Fine. Now the portion is exactly should be size of 300 plus 300. Fine. Now you can see here in this right hand side or left hand side, you can see there is a certain option is given. One, first of all, it is given select image. For selecting the image, if you are by mistake, if you are selected a wrong image, you can reset also, and there is a run button. Okay, this is a run button. Now there we have two options. One is a simple conversion, and second one is a advanced conversion. Along with that, I am having two selection operation. That is two select operation. One for the forward Fourier transformer. Okay, forward Fourier transformation, and second one if you want to study the importance of phasor. Now, if you choose here option, this one, advanced option, now here we can set, okay, here we can manually, we can set the your theta values and R values. Okay, theta, delta theta values, R and delta R values. So we will see what the advanced option will do. Okay, later on. First of all, we see how this simple option is working. Okay, how this simple option is working. Then we will see how advanced option is working with the images. Fine. So let me clear. So any doubts still now? So because you can ask if you have any doubt. If you are having any doubt, you can ask me, because after as we are having only 2 minutes, then do rejoin the next link. So I will show you the next link. Next session I will show you how we will going to implement. Okay, how we are going to perform. So any doubts?
No, sir.
Okay. Can anyone answer why this both the sizes should be same here, input size and output size? What is the reason behind that? क्यों दोनों का साइज सेम है, इनपुट साइज और आउटपुट साइज दोनों का सेम होगा? 300 cos 300, it should be also 300 cos 300. Any answer? Any idea on why it should be always same? Because both are representation of same image. Okay. Now basically we can say signal. Now the signal is represented in a spatial domain, or the signal is represented in a frequency domain. So whatever the way of representation, what will happen? What will happen? The way of representation is different, but that both are representing same image. If the signal of same size, how can it will differ in both the cases? लेकिन अब दोनों अगर एक ही सिग्नल को रिप्रेजेंट कर रहा है, फिर इसका साइज 300 प्लस 300 है, तो यहाँ पर कैसे होगा? इसका भी साइज आपका 300 प्लस 300. Even if number of pixels will also be same. If it is having 300 plus 300, it is having something 940 pixels. Similarly, how many pixels will there here? Here also 9. There will be 4 zeros. Numbers of pixels. Okay. Number of pixels and even size of the images will be same, whether it is in spatial domain or it is frequency domain. Okay, so what we'll do, so do rejoin the same link again for the session 2. Then I will show you how we can perform this experiment. Let me stop here and rejoin again.